What is up, guys? What is up, guys? What is up, guys? We are live right now. We are live. We have just gone live. We have just gone live. What is up, guys? What is up, guys? What is up, guys? Okay, y'all, let's start today's stream. Let's go.
Eyes in the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. If you believe it's true, baby, won't you let the light shine through for you, 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 so let the light shine through.
Okay, you guys couldn't hear me, my bad. Okay, also. Alright, y'all. Welcome to today's stream, bro. Welcome to today's stream. So, today, bro, we're gonna do something similar to yesterday. So, yesterday we did 3 problems. Right now I have prepared, so combined I have prepared even 3 new problems to add to the ones from yesterday. So we have 1, 2, 3, 4, 5, 6, 7, 8. We had 8 yesterday as well. We already went through these ones yesterday. So the stream is gonna end either at the 1 hour mark or either when I run out of problems. Okay, that's when the stream is gonna end. Okay. So let us begin then. So the first one is okay, let's open up Paint so I can draw stuff. Okay, so the first one is lead code find 389, find the difference. Okay, so what is this one? So we are given 2 strings S and T. String S is generated by random shuffling string S and then adding one more letter at a random position. Okay, so shuffling string S and adding one more letter at a random position. So we return the letter that was added to T. So as we can see here, S is A, B, C, D. And then we shuffle it and then we put E at the end. So basically we need to get the letter that is present in T but not present in A. And here we can see S is empty and the letter added to T is Y, so we output Y. Okay, so how have I solved this? How have I solved this? And guys, my solutions are not always the most optimal, but I'm showing you guys how I have done it, and as you can see, it did get accepted. So I decided to make 2 maps, and in the first map we're gonna keep all the letters that are from the string S, and in the second map we're gonna keep all the letters from string T, and I have named the maps accordingly: S map and T map. Okay, so afterwards we will check. So then we will run a for loop to T since T is going to be the longer string, we're gonna run a for loop through T, and if the current character that we are on does not exist inside the S map, or if the count of the character in the S map is less than the count of the character in the T map, then we're going to set the answer to that character, since that is our answer we get. Okay, and then we're gonna return the answer. All right. So let's draw this out. So the current problem is, okay, let me see and try if I can maybe get this like this or something, and then maybe something like this but smaller. Okay, I can make it small. Okay, so this is the problem on lead code. So let me say lead code right here or something. So basically what's gonna happen, so in our S map, we're gonna have the characters A, we're gonna have A, B, C, and D. So this is what our S map is gonna contain. Okay, and then in our T map, we're also gonna have A, B, C, and D, but we're also gonna have E. Okay, so this is our T map. Now obviously these will be key value pairs, and basically, so in maps we store key value pairs. In this case the key is the letter and value is count of that letter. Okay, so, and then basically, so basically one character is gonna be inside of T is not gonna be present inside of one letter inside of the T map is not gonna be present inside the S map. So this is the one, and as we can see, this is our answer as well. This is our output, and yeah, that is basically how we check for it. So we check if the current character of T, if the current letter in T is not present in the S map, or add one more letter. So we can also have a case where the character is present in the S map, but the count of it is less than the amount of times that it appears in the T map. So in such case, let's say we do have also E in the S map. Okay, let's say we also have E in the S map, but we have E twice inside of the T map. So again, inside the S map, E appears only once, and inside the T map, E appears twice. Now, it won't actually be two E's, so the key value pair is going to be E2. This is what the key value pair is going to be, since we can see we are adding up a counter for each letter. Okay, so yeah, this edge case is important because if you don't do it and you only check if the current element, the letter inside of T, is not present in the S map, then this might not be true because it might be present in the S map, so they could have the same amount of key value pairs. But if the T map has the same letter and that letter is counted more times than that letter is counted in the S map, for example, in the S map we have one letter E, as we saw here. If in the S map we have one letter E, in the T map we have two letters E, that means that we also need to say the answer is this letter, because and then add one more letter at a random position. So we can add the same letter, and if we submit this, we'll see that it passes. Okay, there we go. Not the most optimal solution, but it works. Again, guys, this is how I solved it. Hi, bro. Hello. Hello, Shubham. Welcome to the stream, bro. Hello. Welcome. Okay, so that's it for that one. That's it for that one. The next one is, okay, that's it for that one. Let's mark it with light blue or something. Okay, so let's go to the next one. And this solution is big O of n, where n is the number of, actually big O of, it should be big O of n plus m, where, or something. Okay, okay, forget about the big O notation. We're just gonna go on to the next one. We're just gonna go into the next one, which is minimum bit flips to convert number. Okay, so this is a bit manipulation question. Okay, so what do we have to do? Okay, so let's let me delete all this and stuff, and then let me write the, so let's write the current problem is only code or something like that. I'm gonna try to put as much to the left because I know I'm to the right and you guys probably won't be able to see. So a bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. So this is basically, this is also called toggling the bit. So toggling the bit is when if the bit is 0, you turn it to 1, and if it's 1, you turn it to 0. For example, for x, the binary representation is 1, 1, 1, and we may choose any bit, including any leading zeros not shown, and flip it. We can flip the first bit from the right to get 1, 1, 0. Flip the second bit from the right to get 1, 0, 1. Flip the fifth bit from the right, a leading 0, to get 1, 0, 1, 1, 1. Alright, and given two integers start and go, return the minimum number of bit flips to convert start to go. So guys, basically this might look a little complicated, but it's not. So the binary representation of 10 and 7 are 10, 10, 0, 1, 1. We can convert 10 to 7 in 3 steps. Flip the first bit from the right, flip the third bit, flip the fourth bit to the right. So basically what we have to find here, in how many different positions do the bits differ. Okay, so as we can see in this example, where we have 10, and we have 0, 1, 1, 1, we can see the bits differ here. That's 1. They don't differ here. They differ here. That's 2, and they differ here. That's 3. Okay, so that's how we get 3. With 3 and 4, so 3 is 0, 1, 1, and 4 is 1, 0, 0. So the bits also differ in, so these also differ in 3 positions, As we can see, 0 1, that's a one difference, then 0 1, that's the second difference, and then 1 0, that's the third difference, and that's how we get 3. Okay, that's how we get 3. Okay, so what did I do here? So first, I set the bigger number, and then I set the smaller number, and we want to run the while loop while the bigger number is there. Because if we run it if we run the while loop with the smaller number, it's not gonna work. Okay, so basically, I check if go is greater than start. In that case, I'm gonna set bigger to go, because then go is gonna be the bigger number, and I'm gonna set smaller to start. Otherwise, I'm gonna keep it like this. So yeah, this is what we need to do. Find the count of different bits between the two numbers in their binary representation. So we're gonna keep a counter, and while the bigger number is greater than 0, if the current bit between both numbers, basically if they differ, so this could be 0, for example, and this could be 1. So let's say if 0 is not equal to 1, like in this case, right? Okay, so let's say for start equals 3 and go equals 4, that is gonna be 0 1 1, and that's gonna be 1 0 0. Okay, so in the first case, the first bit, as we can see from right to left, is not the same. So this one is not equal to this one, and then we increment the counter, and then we right shift both the numbers, and basically when we right shift, basically we chose the bigger number here because we can right shift it once, twice, 3 times, while the smaller number we can right shift only once, twice, and then it's gonna become 0, and the loop will be over. So that's why we put the bigger number here. And then we have right shifted both of them effectively. This is the next iteration. So in the next iteration, we can see that 1 is not equal to 0 as well. So we're gonna increment the counter. We increment the counter, and then we right shift once more. So this one gets removed and this one gets removed. So now we can see this is also different. So we're gonna increment the counter one last time, and then the big is gonna become 0, small is gonna stay 0, and then we go out of the loop and we return the counter. Okay, guys, then that's basically that one. I think that's basically that one, and if we can submit this even, although I've already submitted this. So this one beats 100% of users on runtime. So I think this is more optimal than the last one. So yeah. And if you guys have any questions, make sure to ask. I'll try to answer them. If you guys have any questions. So okay, that's that one done and dusted. So we're gonna okay, next one is a code forces problem. Okay, short sort. Next one is code forces. So what is this one then? Okay, so actually I didn't even use the whiteboard for that one. Oh wait, I can make it bigger like this. I didn't even know that. Okay, that's useful anyways. So the current done this problem is this problem is 1873. Okay, this problem is this one. If I can I copy this like this or something, and then can I paste it? Okay, I can paste it. Okay, so this problem is code forces. So current problem is code forces